Hello everyone and welcome to It's in the System 1.3. This begins on page 11 in your textbook. Our learning target today is that we'll be able to solve systems graphically and algebraically, and our ACES questions for this problem are 22, 27, 51, and 54 through 62, just the even. Okay? 1-3, booster club members with intersecting lines. What we're going to have here are two equations, and we're going to have to find out what point do we get to where one set of coordinates answers both questions correctly. So that's what we're really looking to find is common solutions to two linear equations. So it tells us at a school band concert, Christopher and Celine sell memberships for the band's booster club. An adult membership costs $10, okay, adult $10, and a student membership costs $5. This is pretty similar to the shirts and caps profit that we did in 1.1. So hopefully maybe think back to that to help you out with this if you need to. At the end of the evening, the students had sold a total of 50 memberships, okay, 50 memberships for a total of $400. So the club president then asked, how many of the new members are adults and how many are students? Okay. Tells us you can answer the question by writing and solving equations that represent the question and the given information. Well, we know that there were a total of 50 memberships between adult memberships and student memberships. So we could have A plus S, okay, equals 50. Right? So the number of adult memberships plus the number of student memberships equals 50 memberships. We also have a dollar amount here, and we know that it costs $10 per adult. Okay, so we could have a 10 for adult plus 5 for a student, and that's going to equal our $400 here. Okay, so we have two equations. And we need to be able to find out how many new members were adults and that were students that fills both of these equations. You should think for a second, pause the video if you need to, think for a second, how might we go about doing that? Well, one way is, and we're not going to do all of A here, just going to skip to 5 where it says, are there any pairs of values for A and S that satisfy both equations? Because that's the one that they were asking on the last page. But one thing we can do is we know we have those two equations. We have A plus S equals 50, okay? And we could make a table for that like we did in 1.1, okay? And we could have the number of adult memberships on one side and the number of student memberships on another. And then over here, again, we can have adults and students, but over here we know that our equation is 10A plus 5S equals 400, okay? So one thing you can do in situations like this is kind of plug and play a little bit. And I would suggest maybe going in increments of 10 here. So if we had 0 adult memberships, we would have to have 50 student memberships. Okay, if we had 10 adult memberships, we would have to have 40 student memberships. Okay, 20 adult, 30 students, so on and so forth as we go through here. And maybe one of these catches, maybe it doesn't. Oops, not 40. We're going the other way on this one. Okay, 20, 40 on this side, give us 10 on this side. Okay, 50 on this side, okay, gives us 10 on this side, or 0 on this side, sorry. sorry, thinking ahead over here to the other side. Over here, if we have 0 adults, okay, then that cancels out our 10a. We have 5s students divided equals 400, divide by 5, s equals 80. Okay, so that does not match up with the set of coordinates over here. Okay, so I would encourage you to go through this in increments of 10 on the adult side, just like we did here. I'll do one more for you so you kind of get maybe a better idea. Okay, so if we have 10 adults times $10, that's $100. We subtract that over here on both sides actually, and that gives us 5s equals 300. We divide by 5, and that now makes it 60 students. Again, those don't match up. So go on and try to find a set that matches up, and then I would graph these. Like this one, if we have 0 adults and 50 students, we'd be here. And then if we had 50 adults, we'd have 0 students, and we'd be right in here, and we could draw our line. Okay. It would be in here somewhere. So that would be the graph of this one. And then once you get this filled out, you can go ahead and graph that as well and see graphically where they intersect. So that would be that part of that. And then we just I was telling you about the graphing over there. It asks you to do that here. Determine the coordinates of that intersection point, as I just talked about. And then over here for part C, I want you to get a little more practice in graphing two equations and finding out where they intersect and what that means. So there's, as I said, each team only does one, so pick one of the four. I don't care which one you pick, just pick one, and go ahead and go through that so you get a little more practice with using graphic methods to solve systems of linear equations. Again, aces for 1, 3, 22, 27, 51, and then the even numbers of 54 through 62. Hope that helps out. Look forward to your comments and questions in class, and we'll see you next time.